Okay, this is the Geometry Chapter 9 review. I'm on the 3rd page now. It says, describe the transformation that will take place if the given shape is reflected over each set of lines. So if we reflect this shape over those lines, this line, and then reflect it again, it's the same as if we had rotated the shape clear up there. So it's the same as a rotation. And we can even determine the degree of rotation by taking whatever angle measure they give between these two lines and doubling it. So 55.3 times 2, or 55.3 plus 55.3, is going to be a 110.6 degree rotation counterclockwise. All right, number 12. These appear to be parallel lines, so if we reflect this across here and reflect it again, that's the same as a translation. Let's see, translation goes TR. Translation, and it's double whatever length this was, so it's saying that it is 3.2. So 3.2 plus 3.2 is 6.4. Translation, 6.4 units. Now it's hard to say the direction, except that it is going to move in a direction that's perpendicular to these lines if they're parallel. So if we translate across parallel, or sorry, if we reflect and reflect across parallel lines, it's the same as a translation along the vector that's perpendicular to those lines, and it would be 6.4 units in that direction. 13. State whether the shapes have line symmetry. If so, draw all the lines of symmetry. I think this one does, yes. If I were to draw a line right down the middle, I think I could fold that shape in half and then it would pretty much line up on itself. I think number 14, this one is also yes, but we could do one down the middle. So a vertical line and a horizontal line. And it looks to me like we could also do a line this way. They would fold on top of themselves, and one this direction. So it appears to have 4 lines of symmetry. Okay, number 15, state whether the figure has rotational symmetry. If so, state the order and magnitude of symmetry. This one looks like it does to me. If this is the original spot, then it could also rotate to here, and then to here, 3, 4, 5, back onto itself. So this has an order of 5. And its magnitude can be found by taking 360 divided by its order. 360 divided by 5. Let's try that out. 360 divided by 5 gives us 72. So our order, or the magnitude of symmetry here is 72 degrees. We got it. Okay, number 16. This one, I think if we took this and just flipped it upside down, right, rotated it 180 degrees. So this one, I can see I would rotate it 180. That's going to be our magnitude. We could find, using the magnitude, find the order by taking 360 divided by 180, which is 2. So that's the order. And I needed to also say that yes, it has symmetry. 17, state whether the figure has plane symmetry, axis symmetry, both, or neither. So plane symmetry would be if we could take like a piece of sheet metal and just slice it through, and both sides would be exactly the same. This image has 1, 2, 3, 4, 5, 6 sides. So I think that we could, if we took it like through this line and exactly through that line, I think we'd cut it right in half. And in fact, there are several places where we could take plane symmetry and go through, but it just asks us if it does have it. So yes on plane symmetry. Axis symmetry would be if we skewer it, if we send something right through it in some way, could we then rotate the image to be right back on itself? And I think we could, even if we skewer it this direction and rotate it like that. So I think it does have both plane symmetry and axis symmetry. 18. Okay, for plane symmetry, I feel like we could slice it like if it went right along there, that it would be cut in half. Now, axis symmetry. I've got to think about this. If I sent a skewer through this direction, it wouldn't happen for sure. But what if I went through like here and it came out the back just right along the vertex there? I think it would have 180-degree axis symmetry there too. So I'm going to say both on this one as well.